What's up guys, this is Massey. Welcome to another video. In this video I want to show you some examples regarding verifying trigonometric identities. First example I have is verify cosine theta over 1 plus sine theta plus 1 plus sine theta over cosine theta equals to 2 secant theta. So what we need to do, we have cosine theta over 1 plus sine theta plus cosine theta, and on top we have sine 1 plus sine theta. When you have the common denominator, we have cosine theta 1 plus sine theta, cosine times cosine, cosine squared theta plus 1 plus sine theta to the power of 2, because these two multiply by each other. Then what we need to do, we need to expand this one. We have cosine squared theta already. 1 plus sine squared, sine theta to the power of 2 is going to be 1 squared plus sine squared plus 2 sine theta over cosine theta times 1 plus sine theta. Cosine squared theta plus sine squared theta is going to be 1. 1 plus 1 is going to be 2. So we have 2 plus 2 sine theta over cosine theta 1 plus sine theta. Then you factor 1 plus sine theta, or you factor 2. It's going to be like that. Write the denominator. As you see here, 1 plus sine theta is both in numerator and denominator, so we can cancel them. And you have 2 over cosine theta, which will be 2 secant theta, because 1 over cosine theta is the same as secant theta. Next example is verify cosine theta over 1 minus sine theta minus cosine theta over 1 plus sine theta equals to 2 tan theta. So what we need to do, we need to have the common denominator, 1 minus sine theta times 1 plus sine theta. Then in the numerator we have cosine theta times 1 plus sine theta minus cosine theta 1 minus sine theta, which is gonna be cosine times 1 cosine theta plus cosine theta sine theta minus cosine theta plus sine times cosine over 1 minus sine squared theta. So that will be cosine theta minus cosine theta cancel out, and here we have cosine theta times sine theta times plus sine theta cosine theta. So it's going to be 2 sine theta cosine theta over cosine squared theta, because 1 minus sine squared is going to be cosine squared. Then you cancel cosine and cosine, is going to be 2 sine theta over cosine theta is going to be 2 tan theta. And that's verified. Next example is verify tan squared theta equals to cosecant squared theta times tan squared theta minus 1. So I start from right hand side. So we have cosecant squared theta times tan squared theta minus 1. So cosecant is 1 over sine, so 1 over sine squared theta times tan squared theta is sine squared over cosine squared theta minus 1. When you simplify that, this sine squared and sine squared cancel out, and we have 1 over cosine squared theta minus 1. Instead of 1, I'm going to write it as a fraction, which we have the same denominator here. So we have the same denominator, cosine squared theta, 1 minus cosine squared theta, which will be sine squared theta. And you know sine over cosine is tan. So we have tan squared theta. And that's verified. Next example is verify secant theta plus tan theta equals to cosine theta over 1 minus sine theta. So what I'm going to do, I'm going to have secant theta plus tan theta equals to 1 over cosine theta plus sine theta over cosine theta. Then I'm gonna say the denominators are the same and add the numerators, 1 plus sine theta. Then what I can do, if you keep an eye on the right hand side of the equation, I'm gonna multiply both sides of the equation by 1 minus sine theta. So that will be 1 plus sine theta times 1 plus minus sine theta. So it will be 1 minus sine squared theta based on difference of squares. And when you multiply the denominators, you have cosine theta times 1 minus sine theta. Then 1 minus sine squared theta will be cosine squared theta over cosine theta 1 minus sine theta. Then you can cancel one of the cosine in the numerator and the cosine in the denominator. So it's going to be cosine over 1 minus sine theta, as you see here on the right hand side of the equation. Next example is cosecant theta over sine theta minus cotangent theta over tan theta equals to 1. So what I'm gonna do, I'm gonna start from the left hand side. We have cosecant theta over sine theta minus cotangent theta over tan theta. Cosecant is 1 over sine divided by sine. Cotangent divided by tan is going to be -1. Or what I'm going to say, let me put it in this way for now. Cosine over sine, sine over cosine. We can write it also in this way as well. So then when you divide 1 over sine theta divided by sine theta is going to be 1 over sine squared theta. And here we're going to have cosine times cosine, cosine squared divided by sine squared theta. So it's going to be 1 minus cosine squared theta over sine squared theta. That's going to be sine squared theta over sine squared theta, which will be equal to 1. Next example is sine theta minus cosine theta to the power of 2 plus sine theta plus cosine theta to the power of 2 equals to 2. We need to expand this. The first one is going to be sine squared theta plus cosine squared theta minus 2 sine theta cosine theta plus this one is going to be sine squared theta plus cosine squared theta plus 2 sine theta cosine theta. These two, when you add them, they're going to cancel out. Sine squared plus cosine squared is 1. Sine squared plus cosine squared is going to be 1. 1 plus 1 is going to be 2. And that's the answer. Next one. It says sine squared theta plus 4 sine theta plus 3 divided by cosine squared theta equals to 3 plus sine theta over 1 minus sine theta. When you factor that, it's going to be sine theta plus 3 times sine theta plus 1 over cosine theta, which we can write it as 1 minus sine squared theta. And 1 minus sine squared theta is going to be 1 minus sine theta times 1 plus sine theta. Then these two cancel out, and we have sine theta plus 3 1 minus sine theta. And as you see here, that's exactly what we have on the right hand side of this equation. Now in this example, we have tan squared theta plus 1 plus tan theta times secant theta equals to 1 plus sine theta over cosine squared theta. So tan squared theta is sine squared theta over cosine squared theta. 1, I'm going to write it as a fraction with the same denominator in here. Tan theta is sine over cosine. Secant is 1 over cosine. So that will be Sine squared plus cosine squared is going to be 1 over cosine squared theta plus sine theta over cosine squared theta, which will be 1 plus sine theta over cosine squared theta. Next example, we need to verify tan compound angle, which is tan x plus y equals to tan x plus tan y divided by 1 minus tan x times tan y. So the first thing I'm going to start, tan is sine over cosine. So tan x plus y will be sine x plus y over cosine x plus y, which when you expand it, we had it before, sine x cosine y plus sine y times cosine x over cosine x times cosine y minus sine x sine y. Now, what I'm gonna do, I'm gonna divide each term by cosine x cosine y. Sine x cosine y divided by cosine x cosine y plus sine y cosine x over cosine x cosine y, cosine x cosine y divided by cosine x cosine y minus sine x sine y divided by cosine x cosine y. Then let's start simplifying it. Here cosine and cosine cancel out. Sine x over cosine x is going to be tan x plus cosine x and cosine x cancel out here. Sine y over cosine y is going to be tan y. And here we have cosine y and cosine y cancel out. Cosine x divided by cosine x is going to be 1. So 1 minus sine x divided by cosine x is tan x. Sine y over cosine y is going to be tan y. So that's proven. So in this example, we need to verify tan x minus y equals to tan x minus tan y over 1 plus tan x tan y. So I'm gonna write it fast now. Sine x minus y over cosine x minus y. So we have sine x cosine y minus sine y cosine x over cosine x cosine y plus sine x sine y. Then you divide both terms by cosine x cosine y. So cosine y cancel out. We have tan x minus cosine x cancel out. We have tan y. Cosine x over cosine x cosine y times over cosine y 1 plus tan x tan y. Now it's proven. Next example says verify sine x plus y times sine x minus y equals to sine squared x minus sine squared y. So we expand this, sine x cosine y plus sine y cosine x multiplied by sine x cosine y minus sine y cosine x. So now you expand it. Sine x cosine y times this guy is going to be sine x squared cosine squared y plus sine y cosine x times this. So it's going to be sine x cosine y sine y cosine x. Then multiply this by this, which will be negative sine y cosine x sine x cosine y, plus, or basically negative, minus sine y cosine x times this one, which is going to be sine squared y cosine squared x. Now, as you see here, these two terms are the same, but they subtract each other, so it's going to be 0. Then we're going to end up having sine squared x cosine squared y minus sine squared y cosine squared x. Now what we can do, instead of cosine squared y, I'm going to write 1 minus sine squared y minus sine squared y 1 minus sine squared x. So that's going to be sine squared x minus sine squared x sine squared y minus sine squared y plus sine squared x sine squared y. These two cancel out, and we're going to have sine squared x minus sine squared y. That's basically is going to be the final answer. Now in this example, it says verify sine x plus y times sine x minus y equals to cosine squared y minus cosine squared x. That's very similar to the previous example. We got to a point from previous example. We got to the point that it was sine squared x cosine squared y minus sine squared y cosine squared x. Now in this case, we're going to get rid of the sines instead of get rid of the cosines. So we have 1 minus cosine squared x times cosine squared y minus 1 minus cosine squared y times cosine squared x, which will be cosine squared y minus cosine squared x cosine squared y minus 1 plus 1 times cosine squared x plus cosine squared y cosine squared x. These two are going to cancel out, and we're going to have cosine squared y minus cosine squared x, as you see here. So that's proven as well. Next example, it says verify cosine x plus y times cosine x minus y equals to cosine squared x minus cosine minus sine squared x minus sine squared y. So this one was extra. Cosine squared x minus sine squared y. So we expand it. Cosine x cosine y minus sine x sine y. Cosine x cosine y plus sine x sine y. So we multiply there. Cosine x squared cosine squared y plus cos x cos y sine x sine y minus sine x sine y cos x cos y minus sine squared x sine squared y. So these two is going to cancel out. So we're going to have cosine squared x cosine squared y minus sine squared x sine squared y. Now in this case, I keep sine x and cosine y, and I change this to 1 minus sine squared x and here I keep it as cosine squared y, and here I have sine squared x, 1 minus cosine squared y. When you multiply it, it's going to be cosine squared y minus sine squared x, cosine squared y minus sine squared x, plus sine squared x cosine squared y. These two is going to cancel out, and we're going to have cosine squared y minus sine squared x as you see it in here. Or you can change it to 1 minus sine squared y, and 1 minus sine squared x is going to cancel out, and we're going to have 1 minus sine squared y minus 1 minus cosine squared x. It's going to be cosine squared x minus sine squared y. So basically that's going to be equal to cosine squared x minus sine squared y, or cosine squared y minus sine squared x. So both of them are correct. So we can say cosine squared x minus sine squared y, and also equals to cosine squared y minus sine squared x. This example, I want to verify tan 2 theta equals to 2 tan theta over 1 minus tan squared theta. We already had tan xy equals to tan x plus tan y over 1 minus tan x tan y. So here, if we have tan 2 theta, it's going to be tan theta plus theta, which is going to be tan theta plus tan theta over 1 minus tan theta, one more time, tan theta, which will be 2 tan theta over 1 minus tan squared theta. Now let's verify this example. Verify cotan x plus y equals to cotan x times cotan y minus 1 over cotan y plus cotan x. So what I'm going to write, I'm going to have cotan x plus y as cosine over sine. We have cosine x, cosine y minus sine x, sine y over sine x cosine y plus sine y cosine x divided by sine x sine y, all terms, cosine x cosine y over sine x sine y minus sine x sine y over sine x sine y, sine x cosine y over sine x sine y plus sine y cosine x sine x sine y. Then now let's start simplifying. So here cosine x over sine x is going to be cotan x, cosine y over sine y is going to be cotan y, sine x over sine x, cosine over y is going to be negative 1, sine x over sine x cancel out, cosine y over sine y is going to be cotan y, plus it's going to be sine y divided by sine y, cosine over sine is going to be cotan x. That's going to be the final answer as you see it here. Now let's look at cotan x minus 1 equals to cotan x times cotan y plus 1 over cotan y minus cotan x. So let's do it quickly. So we have cosine x minus y over sine x minus y, cos x cos y plus sine x sine y, sine x cos y minus sine y cos x. Then we need to divide both sides by sine x sine y. So we have sine x sine y plus sine x sine y over sine x sine y, sine x cosine y over sine x sine y, minus sine y cos x sine x sine y. So now cosine x over sine x is going to be cotan x, cosine y over sine y is going to be cotan y. So cotan x, cotan y, plus sine x over sine x 1, sine y over sine y is going to be 1. So we have sine x over sine x 1, cosine x over cosine y over sine y is going to be cotan y, minus sine y over sine y, cotan over sine is going to be cotan x. That's exactly what you see it in here. Now in this example, it says verify cotan 2 theta equals to cotan squared theta minus 1 over 2 cotan theta. So from 2 examples ago, we had cotan x plus y equals to cotan x cotan y minus 1 over cotan y plus cotan x. Now we can say cotan theta plus theta equals to cotan theta minus 1 cotan theta plus cotan theta. It's going to be cotan squared theta minus 1 over 2 cotan theta. That's exactly what you see here on top. So that's proven.